Math 102, example 3.3.2. Now we have a couple of theorems that we need to talk through. The first is the conjugate zeros theorem. So this says if I have a plus bi is 1, 0, then its conjugate, a minus bi, is also 0. Basically, they come as a pair. I can't get the one without the other. The fundamental theorem of algebra says that each polynomial function of degree 1 or more, which is everything except y equals 0, has at least one complex zero. Now this term complex zero doesn't necessarily mean one of my zeros is going to have an I. When we say complex zeros, that's the complex numbers, but it's also the real numbers. So basically this is saying that every polynomial function of degree 1 or more has at least one zero. And finally, the number of zeros theorem. So my function is degree n, and we say it will therefore have at most n distinct complex zeros. Remember, we might have repeated roots. We saw that with quadratics, and the same thing can happen with higher degree polynomials as well. All right, so the type of problem that we'll see in this section is we're going to be given a polynomial and one of its zeros. So here we're given negative 2 as a 0 and the polynomial x cubed plus x squared minus 8x minus 12. So what I'm going to do is I'm going to do synthetic division with that 0 that I was given. And the number is by itself, which is why I do not change the sign there. So doing synthetic, negative 2 times 1 is negative 2, plus 1 is negative 1, times negative 2 is 2, plus 8 is negative 6, times negative 2 is 12, plus negative 12 is 0. That's my remainder. If we remember from our previous section, a remainder of 0 meant that this is indeed a 0. Now, this is more of a check because we will not be lied to. That 0 will be genuine. So if we don't get a remainder of 0 there, that means we've probably made a mistake. The real reason I'm dividing is to get that quotient, because that is x squared minus x minus 6. So if I take that quotient and set it equal to 0 and solve, that will give me my other zeros. Here, this is a degree 3 polynomial, which means I will have 3 zeros. We were given 1, and I want 2 more. Now, as always, you certainly can use the quadratic formula. This one is factorable, though. So to multiply to negative 6 and add to negative 1, negative 3 and positive 2 will work. And so my other zeros are positive 3 and negative 2. Now you'll notice here, this is actually a repeated 0 then, because I was given negative 2 and it showed up again here. So we do have an example here of a repeated 0. And let's get a picture up here real quick. There's my function, and let's hit graph. And as we hopefully look at that graph, we can see that we are touching at negative 2 because it's repeated. And then we're crossing at positive 3